All right, so tonight we're going to be welcoming James Green. He's a web app developer from Offensive Security, who's been building websites since 2013. He's also really involved with the security community, participating with Detroit B-Sides as well as other conferences over the years. And tonight he's here to present us a topic on web application pen testing with the OWASP JuiceShop. So without further ado, James, take it away.
Awesome, thank you. So I'm going to share my screen. And all right, can you guys see the slides? My first slide. Check that. Yeah. Okay.
Yes.
Cool. And also going to be switching back and forth between Cali, so that's good. All right. So thank you for the introduction. Tonight's talk, walking through the agenda, I'm going to do a quick overview of OWASP and the JuiceShop project itself, as well as the setup, what I'm doing to get it all running. Hopefully you guys can recreate it just as easily. Then I'll go through the steps of pen testing, what it is and how to do it. And once we get through kind of the concepts, we'll go through some details of different vulnerabilities and then how to exploit them. Going to try to do some examples along the way if everything works correctly. If you have any questions, throw it in chat or unmute yourself. I'll do my best to try to stay up on that. Yeah. All right, so again, with the introduction, I'm not going to spend long on this, but I'm James Green. I've got a blog that I rarely use, and I'm a developer at Offensive Security. It's important to say that this is material that I've collected from OWASP or open sources. It's not reflected from anything directly from Offensive Security. Okay, so OWASP, what is it? It's the Open Web App Security Project. It is a massive non-profit organization that puts together different projects, whether that's documentation like vulnerability breakdowns, cheat sheets, different mitigations and security controls that you can implement. All this stuff is available online from them for free. So definitely a great resource to either learn more about security or learning ways to secure your applications and such. Apart from having stuff hosted online, they're also a community group. There are different chapters around the globe. Back in Michigan, there was a couple chapters. The one I was most involved with was OWASP Oakland, and that group met up once a quarter through MySec to, contribute about application security. The other thing is there's also projects like the JuiceShop. So these are, training websites or different applications that, allow you to test the things that OWASP kind of teaches everyone about. So it's a hands-on way of doing things. Besides the JuiceShop, there's the Damn Vulnerable Web App and Matilde, other things like that, that are similar to JuiceShop, but they're more like boot to root CTF boxes. So all those are things that they contribute to. They also have tools. So like, if you guys have heard of Burp Suite, which is a proxy tool, OWASP also has the Z-Attack proxy, or ZAP, which is another proxy tool, which does pretty much everything that Burp Suite does, and it's free to use. So that's just one example, but there's other tools as well. Before I go through the setup, I'm also going to talk about JuiceShop specifically. So that is a Node.js web application. It's built to be intentionally vulnerable. And it's not just a poorly coded website, it's also got a scoreboard and challenges built into it. So as you do different exploitations of vulnerabilities, you'll see a success message when you did something right or not. So it's a real good way to see something specific, like I want to practice cross-site scripting or SQL injection. So it's a good way to get hands-on while also still kind of knowing exactly what you're doing. It was created by Jorn Kimmich. It's maintained on GitHub. And there's a bunch of different ways to set it up. You can use it on Docker, which is what I'm doing, or if you've ever used Heroku before, there's actually a one button install where if you have a Heroku account, you can go to their GitHub page, click the one button setup, enter in some config, and then it's running on a Heroku instance in the cloud. So there's a bunch of different ways that you can get this up and running. What we're doing is, again, using Docker. So that's going to create a local container on my computer. Once that's up and running, we're going to create a port forward on 3000. So when I go to localhost 3000 on my machine, that's going into the container on the same port, and we can interact with the container. On top of that, I'm going to be using a virtual machine with Kali on it, just because I like the operating system. Hopefully that's clear why. And that's got a bunch of tools on it as well that we can use. So I think, yeah, I have steps on that. So I'm running a Kali machine. You don't really have to do web app pen testing. A lot of the stuff you can do just by using the browser itself and the developer tools tab at the bottom of your browser. The VM I'm using is going to be running on a bridge network, so that when I go to my main machine's IP address, port 3000, that actually goes through the container and all the networking runs correctly. If it was host only or anything like that, I might not be able to reach the container directly. So if you have issues, play around with your networking settings if you try to do this later. Also, for some of the more advanced exploits, it's important to have a proxy tool so you can modify the requests as they come through. So either Burp Suite or OWASP Zap are tools that you're going to need to use. It doesn't have to be running on Kali. You can run that on Mac or Windows or Linux and go from there. Why I'm using Kali is because it's just has everything installed. It's got, again, Burp Suite and Zap. It's got Durbuster and other tools that are just already there to make things run better. And personally, I think it looks pretty good, especially with all the new theme updates that have been coming out. So that's our setup. One thing to note is that we're not going to be using the GitHub repo directly or any of the OWASP pages about the project. Because this is commonly used for training, there is a lot of resources online that just tell you how to do these exploits or walk you through the app. So we're going to try to just do this hands-on as we go. All right, so jumping into what is web app pen testing. First, we're going to talk about kind of what you need to get started before you do a web app penetration test. So two things that you really need to pay attention to are scope and permission. Scope is when you sit down with the client or target and clarify what you're doing, right? So any engagement that's not a lab that you're setting up yourself, you need to have in writing clearly laid out what you're supposed to attack, what you're not supposed to do. So some of the things that you'll come across is like what domains, if it's a web app, are you allowed to hit? If there's subdomains like admin.example.com, are you allowed to hit that, or are you just testing example.com? Are you allowed to do brute forcing attempts? There's multiple different ways to do it. One is if you get a password hash from the database, you can do it offline, and normally that's not an issue. But online brute forcing attempts can bring down the server. You can do a denial of service. So if there's a risk of something like that, if you're doing this on a production environment, they might not want you to do that or have you throttle it to a certain percentage. So that's, again, something you need to have laid out beforehand. Also, if social engineering or third-party vendor plugins, if those are going to be included as well. Social engineering would be like if you call into their support desk and try to have them reset a password for you. If you try to, abuse the employees themselves and not just the application. It is a security control and a concern that should be tested, but it's not exactly a technical function of the web app. So whether or not that's something the client wants included, you need to discuss. For the plugins, if there's something like a service, like if they're using Google OAuth to do the login, then you probably don't want to test Google services or anything that they're paying for, which isn't exactly hosted on their site. So going to another service, maybe Another example besides Google would be like if they're using PayPal to do payment processing for e-commerce site, you don't want to be testing the PayPal functionality. And then again, have all this laid out in writing. When they say you're okay to do this, you get that permission in writing in a physical document so that in case anything bad goes down, you have an excuse that's in paper saying why you're doing what you're doing. Again, because this is kind of a setup, we're not doing all that. It's kind of laid out in the project's README what's allowed or not, how you're supposed to even record things and post answers and all that. So yeah, that's it. All right, how to do a web app pen test. So there's a bunch of different methodologies out there. Hopefully, as you play around with this, you kind of find something that works for you. If you've ever heard of the cyber kill chain or the pen tester methodology, there's a bunch of different steps. I believe OWASP and Rapid7 also have web app pen testing methodologies that you can follow. For tonight, just so I can kind of be brief as we go through, I'm only going to be talking about 3: reconnaissance, testing, and recording or reporting. So Recon is, again, kind of doing all of your information gathering, your understanding the system, learning about it before you even try to exploit anything. Testing is when you are looking for vulnerabilities and seeing if any of them are exploitable. And then as you're going through all this, you should be taking notes, finding things to come back to, finding what worked or what didn't work. And then at the end of the engagement, writing everything up in either a bug report or a pen test document, clearly defining what everything you've done, how to recreate it, what your recommendations are, things like that. Okay, so when doing recon, you're learning about the target. You want to know what the application is supposed to be doing, what's its purpose, what technology the application is using, what kind of web server is running the application, what language is used to write the website, what database is being used, what the version numbers are, if there are any third-party plugins, things like that. All of that you can find either through open source intelligence about the website. There's a bunch of things like Shodan or other web scanners online that kind of tell you what's running on a web server. And they can tell you things like the web server version or the application itself. When you're walking through the application, you also want to figure out like what inputs you're allowed to enter, how that information is being used, if it's being displayed on another web page, or if it's being saved somewhere. All of that will tell you like what kind of vulnerabilities you can do. So a common starting point for me, this is coming from, some CTFs and other learning experiences like this. Some common files that people overlook when they're starting out is the robots.txt and security.txt files. So robots.txt is the file that tells the Google crawlbot what parts of the sites to ignore. So if you have a admin console or a site that's restricted to only certain users, most of the time those sections of the application are marked under disallow. So when Google's crawling through your website, it's not going to show up on the search engine when someone starts Googling for your company name. Most of the times, if we see something on robots.txt, that's a dead giveaway that instead of not visiting that section, we do want to visit it. Same thing with security.txt. Most of the time, this only has contact info for like if you're doing part of a bug bounty program or if you're doing like kind of an open engagement. This is the contact info and any kind of encryption keys you might need to get in contact with the security team at your client. Sometimes they can have notes like rules of engagements or certain things to look for, certain things to focus on the security.txt as well. So after you've checked those files, you want to enumerate the happy flow. What I mean by that is, again, pretending to be your standard user. You're going to sign up for an account, figure out what you're supposed to be doing, click all the buttons, follow the links, understand how the application works. You don't want to just jump in instantly, run a scanner, and then try to brute force the first input you see. It's better to understand the whole logic. Is the site an e-commerce store? Is it a social media platform? How are you interacting with other users or others' data? All of that is good stuff to know while you're doing recon. And of course, as you're doing all of this, you want to write everything down so you can further enumerate and come back to it later on while you're doing the pen test. All right, so let's do some of the recon steps live. So I'm going to log into Kali. All right, and just to show you, I have Firefox and I'm connected to the website. So this is my host's IP address. It's running on port 3000. And when I loaded that up, it redirected me into this application. Because it's Node, Node.js, the # is how it differentiates between the IP import and then the rest of the application. So the router will have all of the pages and stuff in the URL after this #. We'll click through that in a bit. I also want to mention that I'm going to be using Burp Suite. So in my preferences, I need to go to settings and then turn on manual proxy configuration. This is just redirecting all of the traffic that's coming through the browser on port 80 to the server and redirecting that to port 8080 on my client host so that Burp Suite can get all this information. I hit OK. This is also Burp Suite off to the side. So right now, I just opened this up. This is a brand new temporary project. There's no config to it whatsoever. This is all default Burp Suite. Right now, we see we haven't loaded anything. If I go back to JuiceShop and refresh it, for one, we can see that it's hanging. It's still trying to run. It hasn't refreshed the page yet. That is because by default, the proxy is turned on and it's intercepting each packet. So we can either forward each of these individually or just turn off the interceptor and that'll reload the page, as you can see in the background. So as Burp Suite is collecting all this, we can see that it is catching some of the stuff and all the results, the pages, that's all going to show up here. So this will be stuff we'll look through in a little bit, but we can see there's API requests, assets. It's getting RESTful data to the front end for you to download, or not download, for your browser to process. So all this will be coming in handy later. Also, I'm going to be using Cherry Tree to write down notes as we go. So things like look at robots.txt. We're going to put that down here, and any results we can also put in here. So let's do that first. We're going to go to robots.txt. And that's not catching it. Okay, there we go. So the difference there was that robots.txt wasn't a part of the Node app. It's just something the web server is also displaying. And we see here that it's saying disallow FTP. So it doesn't want Google to know about this FTP directory. So of course it's saying don't go there. That's the first place we're going to go. And we see here that this is a, it looks like an FTP directory. It's got files and folders, kind of like what you'd see if you were to log into an FTP service on port 21, but this is just a browser version of it. So we can kind of click through these different things. We see coupons, incident support, suspicious errors. Let's click that. All right, so even though clicking that shows us an error that only certain file types are allowed, we still get good information just about this error message. So for one thing, we see that Express is running version 4.17.1. We can use that later as well, see if that's a vulnerable version of Node Express. And we also can see, kind of a developer level breakdown of the error message and see what's falling or what's failing where. This also tells us a bit about how the code is split up, like how the directories are laid out where the files actually are. So let's go back. So we know that MD files like this and PDF files are okay. I don't see any PDFs here, so let's just click legal. And of course, Firefox is going to try to download it instead of just reading it. Let's do this. Nope, still gonna open it. Oh, there's announcements. It's encrypted, so again, we might just have to decrypt that if we can find how that's running it with Python. There's also this package.json.doc file. So that could be an old version of the package.json. Let's actually try to get that. Okay, so instead of downloading it, it's actually pulling it up here. One way we can get around the .md is by doing a null byte character that's %00 and then do .md. What this is doing is it's trying to trick any parsing that says it has to end in MD or PDF. So like this error is saying, right now this file, if you put it to the web application, it would say, oh yeah, it ends with .md. That's the last 3 characters. But when the web server is actually processing it, it's going to treat this null byte like a end of instruction. So it's only going to care about the stuff to the left of it. So if we hit enter, we get bad request. The reason for this is probably because the % is being treated as a character that we don't want it to be treated as. So one way to get around that is to use the developer tools. We're going to go to the console and use encode URI component. So what this does is it takes some string that we're using and puts it into a URL safe version where it's not being executed by the browser, but it gets passed through to the application as the intended value. So if we did %, sorry, it should have been a string. If we do a string like that, we see that % should actually be %25. So if we do %25, 00, we see that it tries to download it. So we can save this file. And we can open this. So here this shows us all of the details about the package from the Node app. We see the name is JuiceShop. We see the author, the homepage, all of this stuff. Probably what we care about the most is the packages that are being included, dependencies and dev dependencies. So we can take this and copy it into our notes or just leave this open for us to see. Really, we'd want to go through each of these and see if any of these are vulnerable because they're either an old version or there's a current exploit for it. How you do that is go to like exploit database or just Googling the package name and then the version number and like vulnerability or something like that and see if anything pops up. So one thing we'll be looking at later is this sanitized HTML and version 1.4.2. And if we have more time, we could go through more of these, but that's just something I'm pointing out. Okay, so let's go back to the regular application. Actually, no, sorry. We looked at robots.txt. Let's look at security.txt as well. So we're going to go to .wellknown/security.txt. So coming here, we see the contact is do not reply at OWASP JuiceShop. They give us an encryption key, and they also have this acknowledgement section. This includes a URL that includes the Node.js syntax. So let's take a look at that first. Oh, sorry about that. That beep messed me up. And that's not what I wanted to paste. Okay, that's more what I expected. Okay, so just by doing that recon, right, we see that there is some stuff that we found. By looking at the security.txt, we found the scoreboard. Also, just viewing that, we're getting this security policy challenge for viewing that security.txt file. And by getting that package.json back file, we did the forgotten developer backup. So that's already 3 challenges just by, doing a little bit of recon. So as you guys see, this is kind of the learning part of the app. This tells you all of the different exploits and vulnerabilities that are available there, and they have different ratings either by type or by difficulty. And there's a bunch of different challenges that you can go through. So let's go back to the main application and see what we can find. All right, so I'm just going to click around, try to see what's possible. So I already clicked on this and see there's a side menu. There's a bunch of pages to look through. There's the icon that takes us back to the search page. There's the search itself. We can type in pretty much anything. One good thing to show up here is that what we input automatically gets returned to us on the following page. That could come in handy. If we click on these results, we see a pop-up where it tells us more about it. There's a link, but there's also reviews. So there's no reviews for this specific one, but it looks like, there's either employee feedback or client feedback that we could use. Maybe we can do a malicious review. Account, looks like we can log in. We can sign up to be a customer for not one, or try to break into someone else's account. We'll do that in a little bit. Let's see what these other pages are. So there's customer feedback. We can submit anonymous feedback. And click through this, give it 1 star. And yep, looks like we can upload anonymous feedback, so that's good. Again, one good thing about clicking through every page is that as we're doing this, Burp Suite is collecting all of this in the background. So we're seeing there's admin data, there's CAPTCHA, there's users data. All of this is getting collected just by us clicking through the different pages. So about us. Looks like this is linked to that legal.md file. Again, we see that it goes to that FTP directory. So they're linking directly to it. It's not exactly private. But that's probably another thing that we can mark up as a finding, saying that there's, an FTP service that should be disabled. That should just be hosted as a web page instead of it being on an FTP server. Also, we see this customer feedback rotating through. I think if we keep going, yep, test anonymous. So there's no approval process or anything like that for this feedback. It just instantly takes the input that we typed in and shows it to users on the about page. Looking through these buttons, it just redirects us to, actual sites away from the application. So we're not going to click any of that. Let's see what other pages there are. There's the photo wall, and there's 3 different results. So it's strange that this isn't loading, but these 2 are. So we can take a closer look at that again with the developer tools. So if we inspect the element, we see that there's span HTML objects with an image inside of it. So let's just compare the 2 and see how different they are. So class container, that's exactly the same. The content class is the same. The image, it looks like it's just the source that's different. So it's still assets, public, images, uploads, but then the name of the file changes, obviously. So instead of it being like 1.jpg, 2.jpg, they have some pretty interesting names for these files. So we already talked about that when we were doing the null pointer, or the null byte, the %00. The URL requires some characters being coded. One of these, for instance, the first one is the £. I'm not sure about the icons. I don't think those need to be encoded, but the £, is used by the Node.js app. So we can try to overwrite that and use the URL encoded value. So let's open that in a new tab. So even going to it directly, we see that it's not loading. You can, again, use the console to figure out what that £, should be. So encode component. And it's %23. So let's replace this. Enter. In doing that, we get the correct file. So again, that's just one thing where the browser or the web server is kind of getting in the way. And it's important to encode this. So this would be another finding that we could write down and record. Even though it's more of like a broken site thing, we do still see that it's missing encoding. I'm surprised emoji worked, but a pound didn't. Yeah, so I think now the way emojis are is that they're not actually used in any kind of routing. So the browser just pushes it straight through to the application. There's special characters like /, $, $, that are being used. And it's just because the emojis don't have a use. Okay. All right, so we've kind of gone through a lot of the, happy flow of this site. We see that it's an e-commerce site. Let's just go back to the main page. There's a bunch of juice-related projects. Some of them have reviews or not. You can purchase them. We didn't go through the actual purchase part of it. If you wanted to click through that, you could probably use something like a test credit card number, just something like 242424 repeated. There's a bunch of different ones on Google if you look them up. Any of those should work with this app if you wanted to go through that process without actually using your credit card data. Let's go through to the next step. All right, so once we know about the application, you kind of have your bearings about what the application does and what kind of inputs you have. It's time to get a little more malicious. You want to kind of start guessing where your vulnerabilities are and if you can exploit them. So again, we know the technology we're using. It's a Node.js app. There's different dependencies in there. It's mostly written in JavaScript. So is there any kind of exploits we can use there? Are any inputs sticking out directly? So any place you can write text and it's being displayed back. So we saw 2 cases of that, either the search bar or putting in customer feedback on the contact page. Both of those are showing our input directly back to us. Either with a search bar, it shows us on the following page, or with the customer feedback, we see that it actually gets saved and shown on the about page. And then again, we want to see if there's any kind of data that we can misuse or misaccess. So what I mean by that is if you're a user and you're checking out with a certain basket, can you view other users' information? If you have saved payment info, is that something you can pull out of the database for another user instead of your own? All that kind of stuff you want to check, and that's where the proxy tool really helps out. So probably one thing that OWASP is most known for is the top 10 collection of the most common vulnerabilities. This is a list that gets updated every couple years that show you what type of vulnerabilities are mostly seen in web applications. So these 10 are injection, broken authentication, sensitive data exposure, XML entities, broken access control, server misconfigurations, cross-site scripting, insecure deserialization, vulnerable components, and insufficient logging. So we're not going to go through each of these. I don't think I have enough time in the last 20 minutes, but we will go through some of the more fun ones. The first one is cross-site scripting. It's not the highest on the list, but it is very prevalent in any application that's using client input. So a lot of the times, developers are only thinking of the good case. You ask for a name, someone gives you their name, you use that data and move forward. They're not expecting the worst case or malicious scenario. So in our case, right, when we're going through that, let's use the search bar. People are expecting them to search for, or sorry, developers are expecting you to search for apple juice and then see your product. They're not expecting you to do something evil and type that in. To be more specific, because this is JavaScript, we want to see if there are any JavaScript specific characters that get returned or if they get scrubbed out. One way to do that is just type in everything. One way that I was told this is called is like just creating a JavaScript fish. So it's literally just using different characters to make it look, you know, kind of like a fish. So you have gills or a top fin and the angle brackets. So when you submit this, if you still see a fish running around the page, that shows you that they're not stripping out anything malicious. Sometimes websites will just strip out anything that could be used for a tag and you're only going to see quotes or the safe info. What we can use for the exploit is actually straight up on the scoreboard page. I'm just going to copy paste for ease. The second challenge here, perform a down cross-site scripting. So it's going to be processed on the client browser with this string. So we're going to create an iframe, which is an HTML tag, and the source is going to run JavaScript that just pops up a box that says XSS. Now doing it exactly like this, we passed the challenge. If we were going to do anything else, it would still run and execute, but we just don't see the green box at the end. So I'm going to copy this. And hit search. And we see this box pops up. So instantly we see this cross-site scripting. It would be safe to stop here. You'd get a result that says, hey, there's cross-site scripting, do something to fix this. It's also possible to get more malicious, right? It's not just, oh, hey, we can pop up a box. That's a low finding. You can do worse things than this. You could do, redirects with JavaScript. You could have links like, for example, if you're doing social engineering, you could take this whole URL that's going to the correct domain, the correct port, that's all right, and then just URL encode the search query. So that just looks like other stuff, but it's on the right website, so most people will still click it. And then have it redirect to a phishing site that you set up to look just like the juice shop and say, give me your login credentials to review your last purchase. Your user will type in their username and password, hit send, you redirect them, everything's fine, they're back on the main website, and you have their credentials. So that's one example of how you can be more malicious with cross-site scripting. You can, get a user's account, not just pop up a box. So this looks like it's not a big deal, but better use of JavaScript will show you that there's, more painful things you can do. Another thing to say is that this is just reflected cross-site scripting. There is another kind which is persistent. Reflected means that it's only showing up because we entered it as an input and hit enter and the current page reloads it. Persisted is when it's saved on the website in some way. So like when we're doing the contact form, there's that feedback section. If that has cross-site scripting, which it most likely does, that's saved to a database or something so they can display it on every request. We don't just have to have this entered. So for example, if we did Apple again, and that same box popped up, that would be saved somewhere that says, hey, every time a page loads, that cross-site script, or sorry, that JavaScript is running. That's the difference between persistent and reflected. So there are different ways to do mitigations for this. One example is sanitization. So this is taking the input and stripping out parts of it so it becomes inert. You can't really run it as JavaScript. So if we were to simplify that last example and just use script tags instead of an iframe, script alert1 would show a box that has 1 in it. Sanitization would strip out the script tags and have it just be the string alert1. The browser would not execute this because it doesn't have the script tags. The second thing is escaping. This is similar to URL encoding, where it's replacing any kind of malicious characters. In our case, it'll be the angle brackets and the slash. Those characters will be replaced with the Unicode example, which is the ampersand LT semicolon for less than, which is the first angle bracket. The browser will still display that correctly. It will not execute it in the browser. Okay, so sanitation and escaping still depends on code. Most of the time, you want to be using a open source library or a product to do this kind of work. You don't want to just create something in-house. Same way the web application can have vulnerabilities, the code that does sanitation and escaping can also have improper logic or vulnerabilities of its own. So one way to show that is to look at that sanitize HTML library that I pointed out of the package. So we're going to do some Googling. I'm going to turn off the proxy just so we don't pick up the Google results. So again, we see that it's sanitize HTML version 142. Okay. So right off the bat, we see that there is this snyk.io, and that gives us some vulnerability information about the package. So here we see there are cross-site scripting vulnerabilities in a package that's supposed to secure against cross-site scripting. So we see that it's anything less than or equal to 142. Let's click and learn about that. Okay, so we can see the issue is that sanitation is not recursive, right? So it's still possible to inject a script or other markup because it's not properly being pulled out of the application. All right, so let's take a look at our JuiceShop again. Turn the proxy back on. I mentioned the comment form earlier, the customer feedback. Let's take a look at that again. So if we were to just do the same thing we did earlier, let's see if I can still paste that. If we were to do this iframe source alert JavaScript, it's most likely that this wouldn't work because it'll be stripped out by that sanitize HTML package. What we could try to do is right off the bat, put something else to the front that will stop it from working. So if we do script I think. So inside of the iframe tag, we're going to bury this script, and I believe that should be the first thing that gets removed by the package. And then the iframe will still run. So we're going to try to make this 5 stars. And see if we can get this to run. So it says, thank you so much for the feedback. Let's go to the about page and see if we get a box to pop up. So right off the bat, we don't see it popping up directly as all the data is loaded, so we might have to wait for it to be displayed in this gallery. So that was the first one we did when we were doing testing with Recon. And all right, looks like I mistyped it, so it didn't work out. But this feedback should have been where it showed up that the persistent cross-site shifting would have done. So I'm going to jump to the next example, but that should be one way that where you can get around mitigations like that. All right. So that's cross-site scripting. Something very similar to that is injection. This used to be SQL injection, entity injection, JSON injection, all that stuff. There are different entries all throughout the OWASP top 10. They compacted all of that down to one entry. So now it's a broader term that just says anywhere additional code or logic can be added to the application through an input. So for us specifically, we're going to do a classic SQL injection example. So a little bit about what SQL injection is. In order to get data from a database, you need to send a command to it to get the subset of data that you want. To do that, you use a query. Same thing when logging in, you take a username and password and use that in the query to see what user exists and if the password is correct. If it is, you return the ID and the user is able to log in. So a common example of how that would look, if it's very simplified, but select ID where the username is username and the password is password. If you type in the correct values, you get the ID back. So where SQL injection comes into play is where you can change that query, where it's just checking the username and the password, and you're changing it to be something that is either always correct and you get an ID back, or you get someone else's information back. So the most obvious example is just saying select the ID from users where the username is an input, password is another input, or true. What this does is instead of saying both of these first two inputs need to be true, it ignores all that and just says or true, because the value itself, true, is always true. So what that'll do is it'll return the first ID in the database, and most of the time that's an admin user, and you instantly get set up in the application. So I think I have more on that. Yeah. So with provided inputs, if you're using, username Johnny and password, even if it's long, it doesn't really matter. You could do whatever and log in. If that doesn't work, you can change the password field or the username field to include that SQL query syntax. So password can be anything. We're going to finish that up with comma or A equals A. For this example, because we're using quotes, I just matched it up, which is why it has to be strings. There's other ways to do this where you can just use a comment and kind of kill off the rest of the query, where it's just where username is equal to Johnny comment, and then the rest of the string after that gets ignored. I kind of show you what that input looks like on the next slide. But that'll change this query to have, kind of that or true statement where we said earlier, where password is equal to anything, which is not the provided password, or A equals A. And because it's the same value, that's always true, and we get the very first user in the database, not just Johnny. So depending on the database you're querying against, there's different syntax to use, but the most common use these kind of inputs. So when you're looking at a application, just kind of go through a list like this. If you're looking for the admin user specifically, just in the username field, try to type admin or root, or if you find anything during Recon that says what the account should be, you can have it here. There's different kinds of variations for how a comment should be written or started. You can use -- which works a lot for me, or the #. You can also use a multi-line comment, which again just starts it and will never end, so it'll go to the end of the query. For the logic, what we're going to do is this end the password input or 1 = 1 and start a comment. So let's take a look at that. We're going to go into the account, log in. Sorry, I said password earlier. We're going to do the injection on the email just so you guys can see it. We're going to look for any user. I'm just going to say X or 1 = 1. A semicolon would end the query, but you don't always have to do that. And then comment, and that ignores the rest of it. Sometimes if there's something weird, you can do different variations of this. I just like doing this setup first, and it works pretty well for me. The password will be commented out thanks to this -- here. So just to get past the front end validation, we're going to say anything and see who we get. All right, so logging in, we do solve the challenge, right? We log in as admin without, breaking the password or anything like that. We can now do more recon. Again, it's important to kind of go back and forth through your steps as you go to different levels as you get more access. So you see here we're logged in as admin. We can see his profile if we click this, right? And we can, either upload a picture or change his avatar. We can set the username, change the email, all that stuff. Yeah. Okay, so that's SQL injection. There's different ways to mitigate this as well. So when you're defining these SQL queries, you shouldn't just do it like that, where username is equal to input and password equals to second input. You want to use either prepared statements or stored procedures. These are ways that it sets up the query that no matter what the input is, it's treated as a string. It doesn't modify the logic of the SQL query. So even if you're using SQL syntax in your username, the single quotes or 1 = 1, all that, it'll just be treated as a string value, not as a syntax to be used in the query. Also, you could have whitelisting enabled, so having checks on the application before sending it to the database to see, like, for example, if it's a username, does this username exist in the database before running the input against the database directly. Also, you can escape all of the input before sending it, so it doesn't run. Again, that's just making it a string. Another exploit is broken authentication. This is probably the last one we're going to get to. So a lot of the time, authentications and sessions are implemented incorrectly. One example of that is weak passwords or poor security questions. So one good way to do that would be to try, again, brute force passwords if they're weak. If you don't have it set up so that you have to set a strong password at the beginning, users can do the easy thing and just use a weak password. So we're going to try to use Perp Suite here and repeat with a list of different passwords to try to see what the admin password actually is. So if we go to login, we see here that we had the login with email being the SQL injection. So we're going to send that to the intruder and change the values of that. So the email, we don't want that to be SQL injection. We want that to be admin at juice. One sec. Juice-shop. Okay. Okay, and the password we're going to change. So right now, Burp Suite tries to take every input and make that a parameter that we're going to change. We don't want to change anything except the password itself. So we're going to highlight this and add that as a position. For the payload, we're going to use one of the word lists that's, well, I generated a short one, but Kali comes with a bunch of them. So we're going to load from file. It's in the user share word list directory. And we're going to use the demo text. So opening this up, we just see, a bunch of common admin passwords, and we're going to hit start attack. Because it's community, it's rate limited, but it works pretty well for us. All right, so going through this, we can just see the status error or the status message that gets returned. 401 is an error and 200 is okay. So we see that the payload of admin123 worked, and that is the admin's password. So because there's not secure password configurations on signup or changing your, editing your profile, that's another example of broken authentication or just poor password security. So that could be another finding. It's 9 o'clock. That's kind of all the time we have tonight. Gonna just jump to the last slide. So that's all the time we have. But yeah, I hope you guys get a chance to download this yourself. Take a chance if you guys are interested, learn about the common vulnerabilities and exploits. There weren't a lot of questions, but I'm always on the PA Hackers Slack or on Twitter. So if you want to reach out, it's greenjam94. I'd be happy to follow up or answer any questions. If you have any questions now, also, if we can go a little bit later, I'd be happy to answer more. Yeah, thank you guys for having me. Yeah, Twitter username. So that's going to be at greenjam94. Yeah, it was a lot of information. Hope it made sense to you guys. I was going quickly through some of it. Awesome. Glad to hear it. Yeah, thanks again for having me.
All right, any more questions? All right, James, thanks for coming out. That was really great. I am sorry we didn't get through all of it. Is there a way you'd be able to make this slideshow available to us?
Yeah, I can share my slides. I will, yeah, make a shareable link for this and get it out to you guys.
Awesome. That'd be greatly appreciated. Yeah, I know I learned a lot on here, so I'm excited to try it out. So yeah, thanks for coming out, and I look forward to hearing from you again.
Yeah, definitely. I'll be in touch. So.